Hello, everyone. Our team name is Runtime Terror, and we'll be working on challenge number 6. So, this is a challenge which is for the national highways, and the task is to optimize and streamline their customer correspondence system. At the moment, these correspondences are saved in a spreadsheet, and their deadlines are set manually. So, our solution for this involves two parts. The first is to create an extensive dashboard which can be used by the team and the management to track which are the top issues and what is their turnaround time and what can be done to speed up the process and meet their deadlines more effectively. The second is to implement a machine learning model to predict the ticket closing time. So here we can see the completion time for the tickets and how many issues were created in a particular month. We also see what were the top issues for that particular time period. Here we can see the number of trends and what is their count. And we also see the average turnaround time in terms of days for each of the trends. In the next slide, we see the number of issues over all time. In this, we can particularly see that there was a large spike during December 2019. And after investigating, it was found that there were a number of new roads that were opened during the time. And there were also some cases of flooding. In this next slide, we see that the data is spread across the days of the weeks and across many years also in a single visualization. One point to be noted over here is that we have customizable filters for each of the dashboards, and these can be set as per the requirement that is there. So this brings us to the first question that was posed to us by the judges. Factors like the days of the week, staffing, and time of the year, how would they impact our solution? So from the dashboard for the days of the week, we noticed that most of the issues came in on a Tuesday, Wednesday, or a Thursday, and there were very few requests that came in on the weekends. So we also see over the entire year that a high volume of issues came in during the winter months, but this is only to exclude 2020, where we suspect that this effect could be due to COVID. So, hence, we would like to recommend that to keep adequate staffing, you need to have high number of staffs during the high volume period. The next slide that we have in the dashboard is a heat map, which explains us the turnaround time of each of the trends across each of our categories. And in this case, the dark red shows that there was a high delay in the turnaround, and the green shows that there was a short time period for the turnaround time. Next, we'll be moving on to the machine learning solution.
The first step of the machine learning pipeline is data engineering. Data engineering involves pre-processing data, which are such as checking for missing values in the dataset and dealing with these missing values. And another aspect to data engineering is checking for inconsistencies. Inconsistencies refer to the manual mistakes that occur while during the data entry process of the whole data collection process. The next step of the machine learning pipeline is feature selection. This involves selecting relevant features for the problem statement, features that actually contribute and add weightage while predicting the target column. To deal with these categorical columns, we do label encoding. However, while doing label encoding, it introduces unnecessary bias while encoding the different categories present in the column. To deal with this issue, we resorted to one-hot encoding. But the issue with one-hot encoding is that it blows up the dimensionality. Also, the category type, it has 13 distinct values. To reduce the dimensionality of this, we classified these as two attributes, such as direct and indirect. Also, the feature trend had 29 distinct values, which again blew up the dimensionality, and which was also reduced and classified into 4 separate groups. The last thing that we addressed in the dataset was the imbalance in the representation of each of the classes. Especially the last category, which are the tickets which are resolved within 10 days, they're very imbalanced, as it is evident in the leftmost graph. To address this issue, we artificially balance the dataset using a technique called stratification. Based on the remaining features, appropriate models such as decision trees and random forests were used. These models were used to identify the inherent patterns present in the dataset and which features actually contribute the most towards classifying a particular column. The feature importance scores generated points towards a minimal contribution from the type feature. It also gave importance to group 1, 3, And 4, this is not what was observed during data exploration. This is a classical condition of the cliched quote, correlation does not imply causation. Another important question that was to be tackled by the problem or the business owner was predicting the number of days in which a particular ticket could be closed. And this is a classical linear regression problem. However, the challenge that we faced with this model was to use the categorical columns to predict a real valued number. So this comes to the point where we address one of the judges' questions: is what limitations did you deal in coming up with? So what we proposed was to collect more, better, and enunciated data to address this particular solution. And some of the other data that could be collected by automating the whole pipeline was collecting geographical data, such as where the tickets are arising from, tracking the issue when it is dependent on other teams. For example, when did a particular team receive the ticket? Was it redirected to someone else? And recording if the issue went back to the client and stopping the clock when it did. The trend type other is the second highest value. This drives the model in an unexplained direction as well. Another question that the judges proposed was, what considerations would you make to create a more effective model? One of the simplest and yet effective solutions to address this particular issue was to build a UI which tracks each one of these tickets. So as evident, as soon as a client logs in a particular or files a particular complaint, a ticket is raised with a unique ticket ID. These ticket ID could be used by the client as well as the business to track the particular problem. On the right hand nav bar, there is a status which tells us the particular status or which team is currently handling the ticket. In the description column listed below, there are additional comments from the client who initially filed the complaint as well. So this concludes our presentation, and thank you so much.